Solving linear inequalities. An inequality is a lot like an equation. The only difference is instead of an equal sign, we're going to have a greater than sign or a less than, or perhaps greater than or equal to, less than or equal to. So the facts are, you solve a linear inequality in exactly the same way you solve a linear equation, which is something I'm sure you all know how to do, with one new rule. And the new rule is when you multiply or divide by a negative number, you switch the inequality symbol. And a good question you might have is, why do we have that rule? Well, let's pick a few numbers here. Let's say I gave you -4 and 8. And I'm sure you would say -4 is less than 8. Now what happens if I take this and divide both sides by -2? -4 divided by -2 is 2. 8 divided by -2 is -4. And you would agree that I would now need to flip the symbol. 2 is greater than -4. And the exact same thing works with multiplication. Let's say I had -6 and -10. -6 is bigger than -10. And let's say I multiply both sides by -3. I would have on this side 18. And I would have 30 over here. And again, you would agree that I need to flip the inequality. So that's what that rule is about. If you multiply or divide by a negative number, you have to flip the inequality. All right, directions. Solve each of the following. Write your answer solution as an inequality. Graph on a number line. And write your answer in interval notation. This is probably something new for you. So we'll go through this carefully here. All right, so to solve, you do it just like you would an equation. So you subtract the 5 on both sides. 2x greater than -8. Notice I did not flip because I'm not multiplying by -5. I'm subtracting -5. And then I divide both sides by 2. Again, I don't flip. I'm dividing by a positive number. So I leave it alone. X greater than -4. So that's what we mean by write it as an inequality. X greater than -4. Draw it on a number line. Your number lines do not need to be anything very fancy. There's -4. There's 0, for example. And the way we do this, since we have just a greater than sign, we put a circle right there. If we had greater than or equal to, we would put a dot. And then we want x to be numbers bigger than -4. Since it's bigger than -4, we shade to the right. Alright, and here's how interval notation works. You take your answer from your number line and you put your smallest thing on the left. The smallest thing is -4. You put the biggest thing on the right. This one goes all the way to infinity. And you're either going to use round brackets or square brackets depending on the situation. Infinity or negative infinity always gets a round bracket. Because we have the greater than and because we have the circle, we do a round bracket. When we have the equal to, we'll do a dot and then we'll do a square bracket. And you'll see that in the very next problem. So let's take a look at that one. Subtract 1 on both sides. -3x. So subtract 1 and I wrote a 2 over there. Greater than or equal to -3. This time we divide, and when we divide, we're dividing by a negative number. We're dividing by -3, so we flip this inequality symbol. X less than or equal to 1. Alright, so that's our one new rule. Divide by that negative number, change that inequality symbol. Number line. There's 0, there's 1. We put a dot on 1. A dot because we have the equal to. So see the difference there. If there's no equal to, it's a circle. Equal to, there's a dot. This time we want numbers smaller than 1. So we shade to the left. For our interval, we look at our number line. We put the smallest number first. This one goes all the way to negative infinity. A comma stops at 1. Infinity or negative infinity always gets a round bracket. This time, because we have the equal, because we have a dot, you get a square bracket. So there's your answer in interval notation. All right, moving on. Number 3. Number 3 I'm going to do twice. And I'll do it twice, and I'll show you why as we go along. What I would do with number 3 is I would begin by subtracting 5x on both sides. Negative 3x plus 5 less than negative 9. I would then subtract 5 on both sides. Negative 3x less than negative 14. And then I have to divide both sides by negative 3. I'll be right up here, I guess. Divide by negative 3. And again, I'm dividing by a negative number, so I flip my symbol. X greater than 14/3. And like I said before, we're going to leave our answer here in fraction form. Please don't convert to decimals. Leave it as a fraction. It's fine. When you go to draw your number line, again, number lines do not need to be very fancy. Here's 0. Here's 14/3. I don't know exactly where it is, but I know it's a positive number, so it's to the right of 0. Now, let's see, it's really, 12 divided by 3 would be 4, so it's a little bit bigger than 4. Not really important. Greater than sign, so a circle. And then we want x to be greater than 14/3. So we shade to the right. Interval notation. Round brackets for both of them. This one on the right goes all the way to infinity. Infinity always gets a round one. On the left, 14/3. 14/3 gets a round one also because of the circle, because there's no equal to. Alright, I said I was going to do this one a second time. And I want to show you something that a lot of students will do on this one. Not that it's wrong, but I think it adds a little confusion to it. So I'm going to write it down again. 2x plus 5 less than 5x minus 9. What I will see a lot of students do is they'll subtract 2x. And it's not a bad thing. The reason they subtract 2x is because they want to keep the x's positive. 5 less than 3x minus 9. And then add 9. 14 less than 3x. Divide by 3, and this is why it wasn't a bad idea to keep those x's positive. When you divide by 3, you don't have to worry about flipping your symbol. 14/3 less than x. Perfectly correct answer. 100% correct. But here's where the problem comes. They'll go to draw a number line. And there's 0. There's 14/3. We'll put a circle there, which is correct, and then they'll shade to the left. And the reason they shade to the left is because they see a less than sign. But you got to understand what this says. This says 14/3 is smaller than the numbers that we want. Since 14/3 is smaller than the number that I want, another way to say that is I want the numbers that are bigger than 14/3. So my suggestion is always put the x's on the left, even if you have to deal with the negatives. And then if you always put the negatives on the left, then a greater than symbol always tells you to shade to the right, and a less than symbol always tells you shade to the left. If you're going to put the x's on the right, it's okay, you can. I will not take off for it. Just be very, very careful when you go to draw your number line, and be very careful about what this tells you. X is bigger than 14/3. You almost have to read it right to left, and you shade that way. Okay? Alright, next we have a couple of what we call compound inequalities. Compound inequalities just means we have two less than symbols involved. Our goal here is to do a couple of steps and get x all by itself in the middle. So when we get all done, we should have something that looks like this. Oops. And it's very much like the problems we did before, except you got to do it in 3 places instead of 2. And here's what I mean by that. To get this x all by itself, the first thing I would do is add 6. If I add 6 there, I have to add 6 there and add 6 there. Normally, back on these other problems, we would say subtract 1 on both sides, subtract 5x on both sides. Well, here when you do something, you've got to do it to 3 places. So 4 less than or equal to 4x less than or equal to 14. And then to get the x all by itself, I divide by 4. And again, the only change is I have to do it in 3 places. 4 divided by 4 is 1. X in the middle. 14 divided by 4, I can reduce that to be 7/2. Alright, so I go to draw my number line. I have 1. And I have 7/2. There's an equal to sign there, so the 1 gets a dot. There's an equal to sign there, so the 7/2 gets a dot. And then x is in the middle, so I want everything in the middle. Interval notation, the smallest thing is a 1. The biggest thing is a 7/2. They both have equals. They both have dots. So they both get square brackets. Alright, last one. Kind of a similar thing. My goal is to get the x all by itself in the middle. To do that, I have to subtract a 1 everywhere. Minus 4 less than minus 2x less than or equal to 6. And then I have to divide by negative 2. And our same rule applies. If I divide by a negative, I have to flip the inequality. In this case, I have to flip both of them. So negative 4 divided by negative 2, that's going to be 2, is greater than x is greater than or equal to negative 3. Now again, be a little bit careful when you go to draw your number line. When you go to draw your number line, negative 3 is the one on the left and 2 is the one on the right. So you got to keep track that this is the small number, this is the big number. It's written backward because we had to divide by that negative 2. Alright, negative 3, that one has the equal to on it. That one gets a dot. 2 does not have an equal to, so that one gets a circle. And then x is in the middle, so we shade in the middle. And in interval notation, we would have negative 3 is the smallest, 2 is the biggest, negative 3 has a dot, negative 3 has an equal, square bracket, 2 has a greater than, no equal to, 2 has a circle, so 2 gets a round one. Okay, so that's it for solving linear inequalities.